Alrighty, so today we're going to be having a look at more sketching of these trig functions, but we're going to be looking at phase shifts as well. So this is going to be a proper little challenge, this one, because there's a lot of stuff to take away. But let's start with the easy things. The a value is what's in front of the cos, so the a value is going to be 5. Note, it is negative 5. We'll talk about that negative in a moment, but let's just think about our amplitude, which is 5. Our median, our d value, which is 1. Period. Now, and period and phase shift are getting lumped in together in this section here. You'll note that we usually write it as b bracket x minus c, not bx minus c. And there's a reason for that. So we actually need to think about it very carefully before we start sketching it. So I would factorize that 4 out. You might go, but pi on 2 doesn't have a common factor of 4. That's fine. We can still factorize it out regardless. So let's rewrite this. And we've got to think about 4 times what equals pi on 2. So there's a few ways you can think about it. One way is to think about you're dividing 4 out of it. And the other way is you can think about, what do I need to change it to? But I can think if it was 4 on 8 and I multiplied it by 4, well, the 4 and the 8 would simplify to a half, which is exactly what I want. And now I've got a little better idea of what my phase shift is. So what that means is that it has been phase shift, our c value is negative pi on 8. Remember, because it's a sign swappy thing. So it's actually been, the whole thing's been moved to the left by pi on 8. I'm going to have to remember that as we go through. Alrighty, so we've looked at most of the values. The last one to look at is the period, so let's do the period now. So the period is equal to 2 pi over b. In this case is 4, so you get 2 pi over 4 pi on 2. And so that's going to be our period, which means it's going to repeat every pi on 2. It's going to repeat quite regularly. So now that we've got all of this information, let's sketch it ignoring one thing. We're going to just ignore this, okay? We're just not going to worry about it. We're going to come back to it in a second. So let's just sketch it with everything else we know, and we'll come back to the c value in a moment. So let's start off with our sketch. So our middle line, our median is 1, so just above the x-axis. The max line is going to be 6. 1 plus 5 is 6. And the min line is going to be negative 4. So let's mark in all of these numbers. So we've got 1, 6, negative 4. And it's a cosine function. Now cosines usually look like this, but I see that there's a negative out the front. Now, a negative out the front of a cosine function, well, that is a vertical reflection, meaning that instead of starting at the top, it is going to start reflected at the bottom. So it has been reflected. Alrighty. So a really good question would be, how much of it do I need to draw? I'm not going to worry about that just yet. That's going to be a problem I'm going to deal with in a second. But for the minute, let's just try and get this period working. So if this is my starting point, the next point will be this one, and this one's point will be at pi on 2, based on my period. Well, that means this is going to be at pi on 4, and this one's going to be pi on 8, which means this one's going to be 3 pi on 8. Okay, so each of these little units is pi on 8 away from each other. And we can carry this on. That's pi on 2. Then this final point over there is going to be pi on 2 plus pi on 2, which is just pi pi. This is going to be 3 pi on 4. And then we can just fill in all the others, which are going to be all 8s. So really, this whole thing is just counting up in 8s. It's just that a lot of the 8s simplify. So we've got pi on 8, 2 pi on 8 simplifies 2, pi on 4, 3 pi on 8, 4 pi on 8, 5 pi on 8, 6 pi on 8, 7 pi on 8, 8 pi on 8. And it works out the whole way through, which is pretty nice. And it also quickly works us out to this bit, which said that we need to go from 0 to pi. So we've actually kind of already done that. Now we've got to do the annoying bit, which is the phase shift. However, the phase shift doesn't look so bad anymore. We're shifting the whole thing to the left by pi on 8. Well, good thing we've been counting in pi on 8. So every single point now, I'm going to do this in green, every single point is going to shift over pi on 8, which is exactly as far to the next little marker I've made. All right, so that's going to happen to every single point. And you can see after actually performing that shift that we're going to get this new function here, which looks like quite a familiar shape. And I just don't mean the fact that it's obviously a trig shape. The other part that makes it look really familiar is that it actually has the sine shape. Look at the start. Starts in the middle, goes up. That's how sine works. So this is probably just a sine function. And in fact, I would be very confident to say that I could write this as, this. Oh, sorry, plus the period. So it'll be 4x. Always a great way to actually check these sorts of functions. But you can see here that this is the original function, and drawing on top of it, you can see that the sine version of the function is exactly the same. Alrighty, so a little bit of sketching functions, including translations. Alrighty, I'll see you in the next video. Bye-bye.